Hello and welcome to all. I hope you all are doing great and keeping healthy. Welcome to my channel Best Math. I am going to start with the grade 10 term 3 exam topics now. I apologize for the delay. Uh, you can see my voice is not 100%, but I'll try my best to get through it. I hope my voice recovers soon and I will anyways start doing the videos because your exams are coming near now. I am Justin D'Souza, your math teacher, and if you have not yet subscribed to my channel, I request you please do subscribe, hit that subscribe button, and do like my videos and share it with your friends who can benefit from it. Before I start with the first video for the exam topic, I will quickly run through the exam scheme. Here you can see there are three parts, part 1, part 2, and part 3. Part 1 and Part 2 each contain 10 questions, but the Part 1 is just 3 marks each, whereas the Part 2 is 5 marks each. And the writing part, the Part 3, is, it can be up to 5 to 8 marks each, the writing part. And all the questions over here must be written in detail in all the steps. I will make sure that I will include all the videos for each type of questions. The two bonus questions can be anything of the topic, anything of the objectives. The objectives which have gone throughout the year. Now, these are all the part A. These are the part 1, part 2, and the part 3. Now, if you're looking for the bonus questions, you can check in the playlist. There are videos which are made for individual lessons. You can try watching them. Any objective from throughout the scheme of work can be asked over there. Please stay tuned to this channel because I will be uploading the videos as soon as possible and whenever I can. So please do be patient and hit the subscribe button so that you will know when and where I post the videos. And all the best for your exams. Please refer these videos and practice more and more by yourself. Do practice a lot. All the best to your students. The first topic is to graph and analyze polynomial functions. Here they have asked you to talk about the end behavior. They have given an equation that is negative 2x cubed. You need to find the leading coefficient, degree, and state the domain and range. It's pretty simple. It might be so many things, but this is the basics of overall graphing. Like you should know all these. Now, one by one, what is the leading coefficient? So by analyzing, you can leading coefficient is whatever is at the beginning. Now, some students do mistake this to be only 2. So don't forget it. Whatever the sign is there, that also must be included. It is a equals minus 2. So make sure you even include the negative sign, negative 2. Then the sign is negative. It's a why this is required, because this graph changes its position. And then we have the degree. So what is the degree? That is the power, the highest power basically. Over here there's only 1, so we write it as 3. And this is odd. This is also very important. If it is odd, the graph will be either like this or like this. Whereas it's an even, it is a parabola. Okay, it'll be up or down depending on positive or negative values. So this is basic. And now over here, this is the graph. I'll tell you why this is the graph. The general form of a cubic, that is x to the power 3 or x to the power 5 or x to the power 7 odd function graphs over 3 would be right side would go up, left side would go down. This is the function. But this is for positive x cube. Now here, since it is negative, all you need to do is swap these. Instead of right side, it will go left side. Instead of left down, it will go right down. That is it. So this is how you get the function. This is the most important thing you must know. That's it. Now, once you know this graph, see where it is going on. Always the odd functions, if they have not restricted the domain, it's always all real numbers. Because see, as x tends to negative infinity, that means over here, as it goes to negative infinity, the graph keeps on moving, right? It'll go, where's the y value? Y is also denoted as f of x. That is going up to infinity. Similarly, as we go on to positive infinity in the x, it goes on to negative infinity, minus infinity. So these are the n behaviors. And then the domain is all real numbers and range is also all real numbers for a cubic graph. So that's it. Now similarly, do pause the video now, solve them by yourselves and then check the answers. Don't directly jump to the answers. As you can see over here, let me just quickly jump through few. Here you can see the degree is 4, degree is always highest power, the degree is 5 here, degree is 7, and so on. Now, what about this? Leading coefficient in this case, the highest degree is coefficient, that is -5. Here the leading coefficient would be 8, and so on. Now, let me just see other thing. Now, one more thing is whether it is a polynomial or not. This is another important thing. Whenever you have negative power or it is a fraction like this, it is not a polynomial. It's always greater than or equal to 0. If it's a 0, then it's just a constant. Say, now we don't have an example over here, but it's fine. But it's always greater than or equal to 0. So what it means is this is a polynomial, x cubed plus 3. Okay. Now, if it is having any negative power or it's a fraction means it's negative power itself when you bring it up, so they are not polynomial equations. So this is not a polynomial because there's negative exponent. This is also not a polynomial. Why? Because there's a negative exponent. Now what about these? You have to employ the method of FOIL, which you have studied in your lessons, where you need to multiply. You need to multiply this with this, this with this, then this with this, and this with this, and then you will get the answer. The degree over here, since x and x is there, it will be x squared, and the leading coefficient would be -2 times 3, that is -6. And that is a parabola, so you can find the domain and everything. So now over here, I'll just quickly go through few of the problems, degree and leading coefficient. Say, for example, this one. You can see the degree is power 5. That's the highest. So that is the degree. And leading coefficient is also 5. Now, since it's an odd number, we know, and it's positive over here, the graph will be something like this and like this. So the domain and range is all real numbers. As x over here starts from negative infinity, you can see over here the graph is going towards negative infinity. And as it is going towards positive infinity, it is also going towards positive infinity. So that is the thing. Similarly, what about, say, I'll just randomly choose this. This is not a polynomial equation. I choose this one over here. Degree is 7 and the leading coefficient is -5. Degree is 7, leading coefficient is -5. Again, it is odd, but it's negative, so it goes like this, up and down. So as x is negative infinity, the y is positive infinity, and x is positive infinity, y is negative infinity. This is how you can solve it easily. Please go through the problems, and over here we have to describe the n behaviors where the graph is given. Now we just look at the graph. As x is towards, it starts with positive infinity, it's up to you. You should just see the 4 options, that's the main thing. Now here, as it is positive infinity, the y value, it's negative. Say negative infinity. And as x goes to the left side, that is negative infinity, y is positive infinity. And now we need to check what is the degree and the coefficient. Now this is a cubic graph. This is a cubic graph. So what do we do is, think when you look at this, you must understand this is a cubic graph. Cubic graph is up and down. But since it is the other side, it is like this, left and right, that means it has a negative leading coefficient. It starts with, say, -2 or -5, x cubed. That would be this graph. I mean, it's not accurate. There is plus or minus, something, or it might be x -2 the whole square, something like that. It varies, but in general, we are just telling leading coefficient is negative, and the degree is 3, and the n behavior. That's it for the first topic. Please do, solve these problems by yourself and then check the answers. The second exam topic is again similar to the first one. Here we need to graph and analyze power functions. It is just like the previous one. We will look into this. Now over here, you have been given a function. Function might vary. you must look into the degree, the sign, the leading coefficient, and then when you graph the basics of it, you will understand the domain and the range. Now over here, you will analyze the given function. The leading coefficient is -10. Over here, don't forget the negative symbol as well. And then the sign of this is negative. And then the degree, that is the highest power, is 6. Now this is even. Even means it's a parabola. It'll be either like this if it was positive, it's like this if it's negative. If it was cubic, then it's like this if it's positive, it will decrease if it's negative. So this is the thing. Now, based on this function, we can understand now, okay, you need to know the graph. Here it's negative, and you don't need to draw the exact graph, you know it'll go something like this. So what is the graph? It's going downwards, it's opening downwards. So it doesn't matter what, your f of x value will be negative both the times. Whereas when x is negative infinity, it is going downwards, minus infinity. Even when it is increasing, also it is going downwards, that is negative infinity. That is what it says. X, as it goes to minus infinity, f of x is minus infinity. As x goes to positive infinity, f of x is negative infinity. That's it. And then over here, domain, it's all real numbers, but the range, as we just now saw over here, is all numbers less than y equals to 0, less than or equal to 0. Why? Because there is no part of the graph that's going upwards. So this is the thing about parabola. So that's the thing. This would be the graph, basic of the graph. Now you can see all the values are below. This is the thing. Now we will see some more functions. One more thing I want to recall over here is, see, over here they have just put minus. It can be 10, or you can see the problems 2, 3, 4. It's fine unless and until there is something added or subtracted. This won't change, and your first two exam topics is mainly dealing with just this, so it doesn't make much of a difference. So it's fine. You should just know the basics of the graph, when it will change into positive, negative, and so on. So in this, you need to graph in this problems, or they've just asked for the domain and range. So it's very simple. If you know the basics of the graph, that is more than enough. Over here, this is again a parabola. So it's positive. If it's a positive parabola, it just opens upwards. So minus infinity or plus infinity, as x tends to minus infinity or plus infinity, f of x is always positive infinity. Whereas the domain is all real numbers, range is all numbers greater than or equal to 0. Why? Because it starts from here now. So 0 to positive infinity. Now the next one over here you can see is a cubic, but it's -2, so it will be just like what we had seen just a while ago. Now this one, don't worry if it's -half. Fraction doesn't matter, the graph will remain the same. Since it's an odd function and it's negative, left side will open upwards, and then if this is the x and y axis, this side will go downwards. So now over here, as x tends to minus infinity, the f of x value goes to positive infinity. And as x tends to positive infinity, that means that when it's going to the right side, where is the graph going? To negative infinity. I hope this is thorough by now. And the domain is, we can see, all real numbers, and range is also all real numbers, because the graph will extend towards both the sides. Here again we have positive parabola, just like this. It's the same thing. Now that's over here we have two more functions. It's an again very simple one. Over here they have to roll to graph. We can easily graph them. Over here it's a parabola. You can graph it and you can tell what's the domain and range. And over here we have a cubic. For whenever the power is cubed, the range and the domain is always all real numbers. So you don't have to worry if it's x to the power 3. Doesn't matter what is there at the right side. It's always up to infinity. So this is the thing. And now one more thing before I finish this video. Over here, it may not be asked, but if it is asked x to the power square plus 2. Imagine there is plus 2, then remember this point will shift up by 2 units. So this graph would be something like this from here, the base. So the range would have been, because the graph is something like this, the range would have been from 2 comma infinity. and this big bracket is for the number because that is included, 0 is included, whereas infinity is never included. It's always just a normal bracket. Now, in case we had, say, x squared minus 3, then over here you would have to, sorry, down, it's positive x squared, so it'll be over here, it would start and it would go something like this. Whereas if it would have been minus x squared minus 3, then it would be like this. So please remember that, and then based on that, you can write the domain and range. The topic 3 is to again use table and graph. In the previous two topics, graphing was not compulsory. You had to know what is the end behaviors or the leading coefficients or the degrees. But here you can see the question is just not x cubed, not only with the degree term. You have many other terms. You need to graph this, and the only method, the best method, is by the table method. So now over here, then you need to check for the relative minima or maxima. So what you have to do is make a table. So what does this mean? It's very simple. You need to just assume x values. Since we know over here it is x to the power 3, it's a cubic graph. And we know the cubic graph, when it's positive, it goes upwards and downwards, something like this. Now, you have to assume the domain. Take some random x values. Okay, just take some x values in the negative side and the positive side, and you will get an understanding of how the graph shapes out. That's what you're trying to do over here now. That's why, how would you do this? This is very simple. You are to just put the f of x as minus 4 and then solve it. Instead of x, it will be minus 4 the whole cube plus minus 4 the whole square minus 5 times minus 4 minus 2. Okay, for one value it's fine. It's easy. It's not easy. It takes time, but it's going to take a long time to do all these values, isn't it? Isn't there any other method? So let me just do this one situation over here. It's minus 4. Then you have to just put it cube plus again minus 4 square minus over here 5 times again minus 4. Use the bracket when it's negative numbers. Lastly, we have minus 2. The answer, okay, I've missed something. Now, it's minus 4 cube minus 4 square. I have written plus, it is minus over here, which I forgot. So this is the correct answer. Be careful as well when you type in the equation. Now over here you can see the answer is minus 30, but what will you do for the other values? It's very insane. I mean, it's an onerous task to keep on changing. So there's a shortcut method. For your exams, do this. There are plenty of shortcuts. To make a table, you can use your calculator. Mode and 7 tells you it's stable. Okay, let's figure out what it is. All you need to do is you need to type this equation in the function, that is f of x, right? Let's type it out. What is x? It is alpha x, so the power 3 plus alpha x again, square, minus 5x minus 2. You're just typing this as it is. Now, let me press equal to. Is there another function? No, we are just dealing with one function. We have to just graph one particular function, so it's fine. We will just press equal to. Don't type anything over here. Now, where do you want to start? Do you want to start from 0, 1, 2? Let us start from, say, a negative value. I'll start from minus 5. Okay, because they're going to compute it, so you can take any number of values. It doesn't matter. Okay, where do you want to end? Let me choose 5 as the ending point. I can type it as 5. And what is the step? Step means what jumps do you give between the values? If I put 2 over here, I started with minus 5, next one will be minus 3, minus 1. 2 numbers will be jumped. But the one, let's give a step of 1 itself. So it'll be minus 4, minus 3, minus 2, and so on. So let me give it as 1. And here you are, the table. Over here, the negative 5 is not there, but it is minus 77. The negative 4 is negative 30. Minus 3 is minus 5, and you can see all the values are just obtained in this table. Up till 5 over here, we have the values. If you have these values, since this is just MCQ, you can easily compare and check the graph. You can say, let's take any point 0, it is minus 2, yes. Let me take 1. 1 is negative 5. Absolutely. 2 is 0. Yes. Minus 1 is 3. Let me check. Yes. All the values correspond. So there'll be only one graph in your answer, which will be the correct graph. So you can easily find it out. And what about the extreme and local maxima and minima? Over here, the relative maxima is at between -2 and -1. You can see it somewhere over here. So that's the thing. Over here, it is given over here near to -2. And over here, what about the maxima? It is at +1. I'm sorry, minima. Relative minima is at -1. That's it. That's how we can solve it. There is one more method. That's another shortcut method. Since generally these are your answers, obviously you can put this in the calculator and graph it. I'll just do it again if you have missed it. All you need to do is mod 7 and type in the equation alpha x cube minus 3 alpha x. Oh, sorry, say look, make sure you're typing it accurately and properly. Double check your equation after you type it. And now press equal to. There's nothing over here, just press equal to. I want to start it from say -5. We are -3 or -4 is also enough, and then end at 4 itself. And now the step was 1. I'm getting the values. You can see they are all the same values. Um, there is value which is differing. Let me just check. Okay, this is the correct values. Now over here there is an error. That is at -2, we need to have -1. Please note that there's a small error over here. Let us check it in the graph, where the graph is also erroneous. At -2, yes, you can see at -2, it's a little bit down. Okay, it's just at the border, so just make note. But whatever you write in the calculator will always be right. They compute it automatically, and you can just check the answer. So now there is one more method to check the graph if they have asked the graph. Now you can just take any value. Take any value. I'll choose 0. Now once you choose that value as 0, you need to substitute x as 0 in this equation. This becomes 0. This becomes 0. What's the answer? 1. So when x is 0, it should be 1. Yes, that corresponds. Let me take 1 as x value. So what do I do? Here, all I need to do is instead of x, it's 1. 1 cube minus 3 into 1 plus 1. And what is the answer? It is -1. So at 1, it was -1. Yes, absolutely right. So when you check 2 or 3 points, you can easily eliminate all the other options and you will be remaining with only one graph. So this is another direct method. And now what is there over here? The zeros are the values which are the x-intercept values. Now look over here. At -2, there is a 0. Okay. It's approximate. Sorry, it's not exactly right. It's approximate. See, it's between -2 and -1. So that's the thing. And there is one more 0 at 0 to 1, and at 1 to 2. So we are just approximating for now. In this third problem, it's just approximation. This is another 0. You're not exactly telling which is the point because we cannot. We just give approximate. And then over here, the relative maximum is over here at -1, whereas the relative minimum is at 1. And then domain and range, as we had seen in the previous topic, it's all real numbers for cubic. Similarly, please do try and solve the others as well. It's very straightforward. Just make sure you put everything correctly in the calculator and you can easily solve them up. And once you know the graph, which is the correct graph, you can easily write the relative minima, maxima, and the domains and everything. So now, okay, I will just tell you what's the difference between absolute maxima and relative maxima. So now if there is a graph like this, say for example, okay, now whatever, forget about the endpoints, we're dealing with the relative or absolute maxima. Now this is a maximum point and this is also a maximum point, right? This is the absolute maximum point because there is no part of the graph that's going above this. You can see this is the topmost point in the graph and there is no more point that goes above it. Usually we will have in a parabola, this is the absolute maxima. But now this one is also maxima, we call it relative maxima. Here as well, you can see that this is a maximum point, but there is a part of graph which is going to infinity. That means it's bigger than that. So we generally call it relative maxima or relative minima in this case, when the domain extends towards infinity. So similarly, please do try to solve these problems by yourself and then check the answers. I hope it is clear. If you have any doubts, do put them in the comment section. And I hope you can understand me properly because my voice is kind of gone since the past few days. Um, I'm trying my best, so I hope it's audible and you're understanding. If you have any doubts, just put them in the comment section. I'll get back to you as soon as possible. So please go through them and then check out the answers. These are all the answers. They're very straightforward. If you understand one concept, you're just translating the same concept to the others. Okay, let me just go through this one over here quickly. You might know this is a piecewise equation. There are three different pieces. There are three different pieces of the equation. So the domain and range, if you graph this, you're going to get this. Now over here, you can carefully see it's x squared. X squared means it's a parabola, but they have told the domain is restricted for less than or equal to -4. So it is just over here. It can't be anything below that. Why? Because only less than or equal to -4 values are included. Whereas if it's a phi, it's a constant line, linear line at -4 to 0. Okay, that's why it's the line. What about the cubic? It's only greater than 0. It's positive, so it will go upside greater than 0, and it's only that much. Now, what is the domain, range, and all the other things? Now, over here you can see the domain is obviously all real numbers. It's extending everywhere. But what about the range? Range is all possible numbers above 0. Now, there's one more thing which you need to note. It's from 0 and it's only greater than 0. 0 is not included, but over here 0 is included, right? Can you see? X is less than or equal to 0, so 0 is included. And even -4 is included, though it's not included over here. Here it's included. Because of these signs, we can make sure they're all real numbers. Okay, though it's straight everywhere, it is included. Now, range is all positive numbers because there's nothing over here which is going beyond x less than x-axis. Relative minima and relative maxima. Now over here there are two relative minimum points which you can see. One is over here. See, it's stopped. This is one relative minima. Why? Because it's added. And then over here is another relative minima, because you can see this is the turning point. So there are two relative minima. It's at -4 and 16, and x is at 0. Okay, and then we have end behaviors. That is, as it goes towards negative infinity, what happens? The y value is going to positive infinity. And even if your x values are going to positive infinity, that is to the right side of the x-axis, the y is going to positive infinity itself. And now, are there any x-intercepts? You might think this is 0, right? But wrong. Why? Because it's not included. See, this is not included. It's only greater than 0. So you start with, say, 0.001. It'll be tiniest point, just more than 0. Whereas this over here is including 0, but still it's not touching the x-axis. It's just over here, right? It touches the y-axis. So the y-intercept you can say is as 4 because it's touching the y-intercept. Over here, you cannot tell this is at 0. This is not the x-intercept. There is no x-intercept. Whereas y-intercept is only at 5 because this is not touching. And this is not at all symmetrical because nothing is matching. So now there's an easy way. If you can see all the 4 options and then look into the questions, and then you can easily deduce the correct answer. So even if you do not know any answer, don't panic. Look into the all 4 options. Go check each and every option and see what it means. Compare it to the question, and then you can eliminate few options, and then you can get the correct answer. So that is the end of the third topic. We will continue the next topic in the next section. In this topic, we need to solve the polynomial equation to quadratic form. Like, we need to reduce it to quadratic form. Now, if you're thinking, what's going on? It's such a huge term. How do we write in quadratic? Let me write the quadratic form first. This is the standard form, ax squared plus bx plus c Now this doesn't look like square and x, no. But now I'll just tell you, if I write x to the power 10 is equal to u, what's going to happen? X to the power 20 can be written as x to the power 10 into x to the power 10, and this is basically u into u, that is u squared, right? So if I assume x to the power 10 as u, I can write it as 4u squared plus 6u plus 15. Now don't you think, sorry for that bad crooked 15, don't you think now this is a quadratic form? It is 4u squared plus 6u plus 15. It's a quadratic form. Now this is the thing, but we need to factor it out. We need to reduce it as much as possible. Now we will see over here. This one can be easily written as this. How do we write it? It's very simple. Now over here, when you look at this first term, okay, there's one more thing. Since you have this in MCQs, you will have 4 options. This is in part 1 or part 2. If any question comes, you'll have 4 options, right? So easily you can expand them. Now let me just expand this over here. It'll be 4. 2 squared is 4. X to the power 20. And 3 into 2. 3 into 2 is 6. That's plus 6. X to the power 10 plus 15. Now this must match the given question. Yes, it's the same thing. This is the easiest way, but how to solve it is also very easy. First, look into these powers. Yes, I can reduce them as x to the power 10. Okay. But now if you look closely, this can be written as 2 square. 4 is 2 square. So how about I write 2x to the power 10 the whole square plus. Now if I've written this this term as 2x power 10, I need to write 2 over here as well. Okay. So now these two terms are same. This is like x squared plus x. But there's some coefficient behind this. What is that? 6 times 2 is 3. Yes, sorry. 2 times 3 is 6, because we need to have the 6, or you can just divide it by 6 divided by 2 is 3. So we need to write 3 outside the bracket. Now these two terms must be plus 15. This constant doesn't matter. So this is your answer. Now it's C basically. X squared, x and C. Sorry for my voice. Now that's the answer over here. Just remember, when you square it over here, you're gonna get the question. Now we will see one more problem. Now look at this problem carefully. If you see closely, it's x to the power 6 and x squared. Do you think you can reduce this as quadratic? It's not possible. If this was 3, yes, I can write this as x to the power 3 the whole square or something. This can be written, but now no, it's not possible, because they are, it's not you can't write it in terms of squares. See, this must be x squared, so you must write x squared the whole square, which is not possible. In the previous one we wrote x power 10 and x power 10 the whole square, right? We can't reduce it, so this cannot be written in quadratic form. Same way, do solve these questions by yourself and then check the answers. There's one more method which I told you initially to check the shortcut method. All you need to do is solve this. Now, for example, negative 15 is outside, x to the power 4. Simplify this. 18 over here, x squared minus 4. Yes, this is correct. It's the same as question. Now, over here, looking at this, it's not possible. Very easy to say. Now, what about this? Let's write 4 outside. 2 squared is again 4 into 4. And x to the power 5 and 2, it will be 10. Plus 1 times 2 is 2. X to the power 5 plus 6. Now, when we simplify, this will be 16. Yes, that's the question. Now, over here, 3 squared is 9. X to the power 4 times 2 is 8. Minus 7 times 3 is 21. X power 4 plus 12. Yes, that's the same as question. You can easily solve them up. Compare it with your questions. You will easily get the answer. Now over here, they have asked us to solve these. How you can solve them is similarly, just like what we had done a while ago. But now there's a special thing over here. You can't directly solve them in calculator, isn't it? Same step what we did just now. This can be written as I will tell you one thing. Instead of x, just take it as u, sorry, I'll write over here, u is equal to x squared, okay? So now u is x squared, so this is u squared minus 3u minus 10. Now this can be put in the calculator and solved because it's a quadratic form. So all you're doing is over here, you just use the calculator now and simplify. Okay, okay, brilliant. Now over here, this is u squared minus 3u minus 10 more phi 3. This is the quadratic form. To solve quadratic form, you have to just put the coefficients 1 minus 3 minus 10. Same way you can do the same thing for other problems, but only thing over here is, you see, this is the standard form, equal 0 must be on the other side, everywhere is the same. So you need to just put u is equal to x squared. You can see everywhere it will work the same. Now what's the answer? I got x is equal to x1 is equal to 5. Now what about the next one? Minus 2. But is this correct? Sorry, I have to write u over here because I've assumed it as u. I've taken it as u. Sorry for that. Oh, I'm missing many things. Okay, this is the thing now. Now, what next? Look carefully. Your answer for this is true, but u is not the answer. U is equal to x squared, isn't it? So now, over here, you have substituted. Look over here. You have substituted 1, minus 3, and minus 10. Okay, that's fine. This is minus 3. You can see up over here. So now you need to substitute this as x squared equals 5. So now what is the answer for x squared equals 5? X will be equal to plus or minus root 5. And what about over here? X squared equals negative 2. Whenever you have negative 2, it will be root of negative 2, which is not possible. You have an imaginary number. So x is equal to negative 1 root and negative 2. So this will be plus or minus I. So basically the answer is root 2 plus or minus root 2i. So this would be the answer. The answers are 4 over here. It'll be, you can see the answer over here. It's plus or minus root 5 and plus or minus I root 2 or 2 root 2i. Let me solve one more the same method. Let me take this for example. Now over here we always have to reduce it as much as possible. Now when I look over here, I can see 9 is a perfect square, so I can write 3x squared. So let me assume u to be 3x squared. So now can I simplify this? Yes, you can write it as 3x squared. Sorry, let me write it as u squared. Why? Because if I square this entire thing, I'm gonna get 9x to the power 4. So this is equivalent to squaring it. So looking at this, it's a perfect square. Yes. So I can write 3x. Okay, now only thing is I have written in the quadratic form, which we did in the last section. Now, what is the next thing? I need to split this into 3x squared. And so basically divide 27 by 3, you will get 9u. How do you understand this? It's very simple. You have assumed 3x squared as u from this. You have to just transfer the same thing over here. But remember, whatever the number is, they divide 27 by that, because we can write 9 into 3x squared now. Okay, when you multiply this, it's going to be 27x squared. So that's why I've written it like this. And then lastly, we have 20. This is a constant, it does not matter. Now, more phi 3, substitute these values. What is before u square? That's 1 minus 9 then. Why? Because before u it's minus 9. And lastly, we have 20. What are the answers? U is equal to phi, and we have u is equal to 4. Only two answers, x1 and x2. U is 5 and u is 4. So let me write it properly. U is 5, u is 4. Sorry for that. U is 4 over here. And all you need to do is, what is u? You assumed u to be over here. Sorry, I've already written it. 3x squared, right? So now write 3x squared equals 5 and simplify this. I'll do it over here. Now it'll be x, take this 3 to the other side. It's going to be x squared equals 5 by 3. Now if you have to remove the square root, square on both the sides. So the answer will be root 5 by 3. Plus or minus is important. And over here as well, it will be 3x squared equals 4, or x would be equal to square root 4 by 3 plus or minus over here. Because always when we have square root or even roots, we are even radical powers, even radical symbols, it is always plus or minus. So that would be the answer. You can see it is okay. Now what they have done is they have just removed it. That's fine. But this is the same answer over here. You can write this as, you can simplify it. Now I will show you how it is done, simplification. One of the easiest way to simplify is just go to mode 1, write root 4 divided by 3, and you will get the simplification. Okay, so this is the thing. Or if I just change it to 5, I'll also directly get it simplified. Now what happens is generally they don't write everything in cube root. They will try to remove common terms out. So how they do over here is basically, now this is 5, so they multiply 5 up and down. So you're not doing anything. It's multiplying 5 up and down, and this will be 3 squared, which can be removed out, or you can remove the cube root, and over here up only cube root remains for 15. So that's the thing. But if it's confusing, don't worry. All you need to do is, from what we had got, sorry, I'll just go back. Whatever we got, just substitute in the calculator, you will get the answer. But always remember there is plus or minus, and since there is x to the power 4, there are 4 roots. And whenever you get a negative sign, there is no negative sign over here, we didn't find any, so it is just plus or minus numbers. Wherever there was a negative sign inside square root, whereas over here or over here, you must write I outside. So this is it. Please try solving it by yourself and then check the answers. The fifth topic is on synthetic substitution. It's similar to division, but it's very simpler. So what happens is, we will come across synthetic division in the future stage, where it's a particular method to divide polynomials with binomial. So only if there is a binomial. Binomial is like this, x plus 2 or x minus 2 or something like this. You're dividing a polynomial with this, then it's possible to do synthetic substitution. Now over here, you do not need to do that for now. All you need to see is what have they given. You have to do synthetic substitution to find f of 2. It's basically finding the function of x at the term 2, in the sense, instead of x you're just putting 2 and solving. So this is one of the most easy and basic problem. All you need to do over here is, wherever is the equation, instead of the function, put 2 first. It will be 2 squared plus 6 multiplied by 2. You do not need to use the brackets for positive, but I'm using the brackets now because I have to use even minus 1, right? So then plus 5. And always using brackets is a good adequate. It'll make it much easier and clearer when you're substituting. Now press equal to, your answer is 21. But that is f of 2. What's the another answer? You need to find for f of 1. So negative 1, that is over here, minus 1, and over here to be minus 1. And that's the answer, 21 and 0. Same way you can solve all these problems. It doesn't matter if they are big or small. Now here, let me do a big one. This one, it's just going to take time. There's nothing else over here. I'll keep minus 1 as it is for now. I'll solve this first. To the power 6. Then we have minus 2. So it's minus 2 into minus 1, the whole power 5. And then we have x to the power 4, that is minus 1 to the power 4, plus again minus 1 to the power 3 minus 9 to the power to the x to the power minus 2 minus 1 to the power 2, and lastly we have negative 20. One thing I want to remind you is whenever you have such a big problem, do double check your question, because it's very easy to go wrong somewhere in the middle. Okay, it's correct. And if you want, you can avoid this two signs, multiplication sign, sorry, because it'll give you the same answer. If you use the bracket, it'll be multiplied. And over here it's plus x to the power 4 plus x to the power 3 minus 9. Over here I can remove this as well, or you can keep it. It's up to you, whichever makes it simple or easy for you. Press equal to, the answer is negative 26. Remember, I did minus 2. All I need to do is change this to 2 and I will get the next answer. I will just do it because it's already typed. Once you type one of the term, the other term is just very easy. Just you have to change it over here. So make sure you properly input the values. The entire equation must be accurate. Now I just missed the bracket. Okay, 2. And lastly it's minus 20 and the answer. Okay, I have done some mistake. So now let me just go back and check. It's very crucial to put each and every term correctly. Now let me check what is the mistake I have done over here. So you can see I have put minus 2 over here, minus 2 to the power 5. The negative remains when it's odd powers. See, this is, again, it's good that it happened. Now please do not repeat the mistake which I just now did in the exam. It's very easy to go wrong. Please double check your equation once you have typed it all in, and then you will get the right answer. So this is it. It's a very simple and very basic type of problem. All you have to do is synthetic substitution, means whatever is given, you need to substitute. That's basically the remainder, which we'll learn a bit more in the coming topics. Hello all, we move on to the sixth topic. This is a bit lengthy topic. It's not that easy and it's not that difficult as well. You need more practice for this topic. Once you practice, it'll be very easy. Now here they have asked you to find the number and type of roots. There is twofold of the problems. The first type is one method and the second type is one more method. We will look into both of them. They've asked to solve x to the power 4 plus 49x squared equals 0. Let me directly go into the topic now to solve the problem. Here, you need to simplify this. This is the original equation. All you need to take is remove common terms out. You can see x to the power 2 is common. Remove it out. You're remaining with x squared plus 49. Now, what this means is you're multiplying two terms, isn't it? And the answer is 0. When does this happen? So now imagine your answer is 0. You're multiplying a number with some other number. So say I multiply 7 with which number will give me 0? Obviously it must be 0. Or it can be 0 multiplied by some other number, 8. The answer will be 0. So here what we are trying to imply is either this or this number is 0. So we need to equate them both as 0. So either this term or the inside term must be equal to 0. So now that is the zero product property. We solve this, take the square root on both the sides at 0. Over here, you can use the calculator by mod phi 3. Let's do that. You can use mod phi and 3 and solve it up. It's 1. There is no x term, so it's 0. And then the last term is 49. Or you can just take this 49 to the other side. It'll be x squared equals negative 49. Square root on both the sides would mean x equals, that root negative sign will be I plus or minus 7. Sorry, not root 49, it's 7. So this would be the answer. But even in the calculator, it will give you the same thing, 7i and minus 7i, because it's plus or minus, isn't it? So you will get the same answer over here. You can simplify plus or minus 7i. Now, when I wrote it, I wrote plus or minus. I was separate because but remember, this is multiplication over here. I should have written it over here, or I should have put this. This is the correct way to write it. Now over here, what we need to do is state the number and the type of roots. So here the degree is what? 4. So 4 degree means there must be 4 roots or 4 solutions, 4 answers. So now how many answers did we find? We found plus or minus 7i. That is 2 over here. That is plus 7i minus 7i. And there's only 1 0, right? That means here this is having it's multiplicity of 2. That means this is double root basically, because you found out these two. Okay, here since it might have touched like this, exactly, we consider that as double root. Basically you're repeating this 2 times. So there are two real roots, or the root is repeated, we can say. That is 0 and 0. And then there are 2 imaginary roots because it is power 4. If it was power 3, it was just 3 roots. Okay, fine. But since it's power 4, we know that there will be 4. But since this is repeated twice, we have 2 of this and this. And remember, the imaginary number will always be in pairs. It will be plus or minus 7i or 2i. It will be plus or minus. So always it happens. Now let us see these problems. These are pretty straightforward. You can try solving them by yourselves. This is a linear function. You can just take it to the other side and solve. Negative 12 by 5. It's just one real root. Now if it's, we will just go through these, few of them. If it is x to the power 2, it's straight in calculator. Let me just recall. Mod phi 3. How do we solve? 1, minus 4, and 40. Very straightforward. Over here we have got plus 2 plus 6i, 2 minus 6i. These are the 2 imaginary roots. Now similarly you can do all the 2. I will do 3 as well to the power 3, and then I'll come to this 4 and 5. So over here, let me see this one. So for example, then you have to go more 5 and then 4. That gives you cubic solving. Now here is 1 minus 6, 7, and there is no constant, it's 0. So the answers are 3 plus or minus root I, then 0. Now over here you must know there is 2 times. Wait, let me just double check it. Now this is the root. Let me just see what mistake did I do. It's 1 minus 6, 7, and 0. Yes, it's all right. It's 3. That is 3 plus root 2. Okay. 3 minus root 2. Yeah, it's 0. Sorry, my bad. I was thinking there are 4 roots. This is the correct answers. Whatever we got, there's no problem at all. There are 3 real roots. Okay. Whenever you must always look at this. I just got confused because the last problem which we solved had 4, right? So I in my mind I was thinking there are 4 roots, but look at this, which is the degree. It is power 3. There are 3 roots then. So if it is power 2, there are 2 roots only. Now let us look at the 4, which we have already done before. If you're thinking about the 4, just see the beginning of the video. We have done this. Similarly, you can solve it. You can take the common term, or you can take the common numbers and simplify it. You need to equate 2 things. But what about this 5? That is also the same thing. Now over here, you can simplify this. First, you need to remove common term. That is x to the power 3 is common. What is remaining? X squared plus, over here there is 4 equals 0. So now this will be equal to 0, or this will be equal to 0. So now equate x cubed equal to 0. What is the answer? X is equal to 0. But how many roots are there? It is not 2 repeated, it's 3. Now it's 1, 2, 3 zeros. Why? Because x cube is 0. We are getting 0, yes, but there are supposed to be 3 real roots. Okay, 3 real roots which are 0. Now the remaining term can be solved in the calculator. Mod phi and 3. Over here you need to put the coefficients. 1, there is no x term, and 4, you will get 2i and minus 2i. So plus or minus 2i, that's 2 imaginary roots. Similarly, we can solve the others. Please do try it by solving yourselves. Now if you're thinking over here, what's going to happen? See, here you need to remove x common out, and then you need to solve. It will be x to the power 4 minus 8x squared plus 16. Now if you're thinking how to solve this, You need to remember the problem which we had solved in the previous videos. We had done it in the quadratic form. You need to employ that. So over here it will be x. You can do u substitution. Consider u as x squared, and then it will be u squared minus 8u plus 16. And now you can easily solve it up. What do you have to do? You need to put this in the calculator, simplify, solve, and you will get the answer. So this is how we can try them all. This will be equal to 0, and these, don't forget, whatever the answer you get needs to be solved again as x squared and then simplify it. So please do try them by yourselves, all of these problems, and then check the answers. All the answers are over here. Now we will go to the next type where we use Descartes rule. Now this is not Descartes, it's a Descartes. It's a French name, I believe. It's pronounced Descartes. In English, generally, it's pronounced as Descartes. Anyways, now what this mathematician did was, he told if you have any equation, if you do few steps, you can understand how many maximum real roots or imaginary roots can be possible. So this was wonderful. Let's see how. Now now this is a big equation, right? X to the power 5. You must do this method. That's the thing. There are no proper shortcuts, because the shortcuts may not work all the time, so you cannot bank on them. So it is better you be thorough with this method. Don't try for the shortcuts in this. Now we find the possible positive real zeros, right? So now first of all, you need to count the sign changing. How many times it changes its sign? It's positive at the beginning, right? X squared, x to the power 5 is positive. It's one sign change. From positive it became negative over here. So plus to minus 1. Then it's same minus. Then from here to here, see over here, one second, let me make it clear. One sign change. Here there is no sign change. It is negative to negative itself. But again, negative to positive, there's another sign change, second. Okay, yes. And then again over here you can see plus to minus, and then again minus to plus. So there is 3 and 4 sign changes. This is what you're counting. There are 4 sign changes. So if 4 sign changes are there, there are either 4 or 2 or 0. It should be always multiples of 2. Okay, there is either 4, 2 or 0 positive real zeros. That is what it says. Now what about the imaginary one? It's not over. That's just the part 1. Now you need to change this x into minus. So what you need to do is, instead of x over here, you need to substitute minus x. So f of x will be f of, so instead of f of x, you put f of minus x. And then now you do the same thing. Now over here, what happens? Before, when you simplify, remember when it's odd powers, the negative sign sustains, whereas if it's even powers, the negative sign diminishes. So why? Because whenever it is odd power, negative will be there. You can try this in calculator. Take any number, say 5 to the minus 5 to the power 5. Or when it's odd, okay, I'm just messing it up. Okay, now that was very clumsy of me. Now 5, it's minus, right? But now let me make it an even power. It's always positive. So the same thing, over here negative remains, over here positive, but this minus sign remains. Negative becomes positive because it's odd, and similarly it's changed. Now all you need to do is count the sign changes again. There is no sign change from 1 to 2, but here it's negative to positive. Yes, one sign change, then there is no sign changes at all. So now what it means is there is only how much? One sign change. Look, no sign change, no, only one sign change. Then it's always positive. There is only one change in sign. So therefore, there is one negative real zero. So this is, we came to know how many positive real zeros were there. Just a while ago, it was either so after this, we can count 4, 2, or 0. And there is one negative real zero. And the last one is writing this table. Now, if you know how many positive real zeros and how many negative real zeros are there, and the remaining ones has to be imaginary. Now, in this case, if there are 4 positive, maximum 4 positive real zeros and 1 negative, then there is 0 imaginary, because the maximum is 5. Total is only 5. Same way, now let's reduce this. It can be 2, but negative real zeros is maximum 1. So imaginary can be 2. Add them all, it should be 5. Same way, now it can be 0 as well. Sometimes there'll be only imaginary. Now here this 1 is definite. And now you have to write 4 imaginary, and this is the answer. Remember, if it's 1, it has to be there. If it is 2, it can be 2 minus 2, 0. So this is the thing. That's how we do it. If it was 4, 4, 2, 0. If it was 1, it'll be only 1. But if it was 3, it'll be 3, 1. That's it. So now, this is how, please do try these problems by yourself. Pause the video, solve it, and then you can check with the answers. All the answers are there. Now you have to just make the table and do it. It is lengthy, but it's simple. Just count the change in sign. Change the x to minus x, count the change in sign, and do the table. The seventh topic is another easy topic. Here we have to just find the sums, differences, products, or quotients of functions. That is basically f plus g of x, or f minus, this is subtraction or difference. The product is by this dot, plus is addition or sums, and division or the quotient is f by g. Now the functions f of x is 2x and g of x is minus 4x plus 5. All you need to do is add this up. That's it. Now let's go one by one. The first one, f plus g of whole x. All you need to do is add f of x and g of x. That's it. There's nothing much over here. So it'll be 2x times minus 4x. Now remember, use brackets because it's plus and minus. In this case, because it's plus, it doesn't make a difference, but it'll make a lot of difference when you subtract. So f of x is just a single term, so I just write it as 2x. It's a monomial, where this over here is a binomial, so we will use the bracket. Minus 4x plus 5, you can see that's the violet color, whereas the green color is over here, olive green, is 2x. Now next thing would be just add them up. 2x minus 4x is minus 2x, then plus 5. All you need to do is, this is it, that's the answer, nothing else. All you need to do is adding them up. Now subtracting is again simpler. Again the same way, all you need to do is minus, but just remember you need to multiply this negative sign inside the brackets. So it becomes 2x plus 4x minus 5. Because distribute this negative sign, use the distributive property. And now when you add it, it'll be 4x plus 2x minus 5. The answer is 6x minus 5. To find the product, all you need to do is find, multiplying. So you need to multiply f of x and g of x. How do you do? Distributive property again. 2x times minus 4x would be negative 8x squared, and 2x times 5 is 10x. That's it. That's the answer. It's very, very basic, very simple. And 4 divided by g of x, again another simple type. Same functions. Now over here, they don't ask you to do the long division or anything. Just write them as a fraction. 2x is up above, numerator, negative 4x plus 5. But here they usually ask you to write the undefined number. So we know no number can be divided by 0, because this is a very complicated part. What do you mean exactly by 0? It's basically nothing. So how many times can you divide any number by nothing? It can be 1, 10, 100, undefined times, or infinite times. So it will correspond towards infinity, but the answer is generally undefined. So you can't have denominator as 0. If you graph such, it'll be an asymptote. There will be nothing. We won't get this answer. So we just avoid those values. How will you find the undefined value of x over here in this case? All you need to do is whatever is the denominator, just equate it to 0. Just make it equal to 0. So what is going to happen? That is, take this to the other, take 4x to the other side. So make it positive. So 5 equals 4x, and 4 goes to the other side. It'll be 5 by 4 equals to x. So basically when x is 5 by 4 here, this will be undefined. So avoid this term. So this should not be equal. X should never be equal to 5 by 4. Any value other than that is 5. This is how we solve this very basic, very simple problem. Now, all these problems you need to do it by yourself because they are very straightforward. There is nothing over here. It's very, very simple. Just add them up. X plus 5x is 6x. Minus and minus will be adding, but you need to write the negative sign. Same way over here, you need to subtract. It'll be minus 4x and plus 1. You need to multiply these. You can use the FOIL method, binomial multiplication. And lastly, just write them divided by. Find the non-equal to sign, in the sense, when does this become undefined? It will be 5x equals 2x should not be equal to 2 by 5. So that's how you find the undefined. Please try all of these by yourself and then check the answer. It is very simple. Now I'll just quickly run through this. You can see there is x squared, x and minus a constant term. You can't add them. You should just write those together. See, x squared plus x minus 5. Even subtraction is just these two sign changes. That's it. Multiplication can be done. Obviously, you can multiply any terms. Doesn't matter the power. Only adding and subtracting is for like terms, whereas multiplication can be done for unlike terms. Quotient is just by writing the fraction. So same way, do it by yourself and then later on check the answers. So that's it, only 6 questions in this topic. Please solve them by yourself and then refer to the answers. The 8th topic is to find inverse of relations. There are 2 types of problems in this. The first type is very easy, where coordinate points are given. Say, for example, you have been told the vertices minus 8, 6, 6, minus 2, 4, minus 6 are of a triangle. We need to find the inverse of this. So basically, what is inverse? Before we start solving, inverse is something that is opposite. Now, if it is x and y, inverse would make it y and x, something like this. Okay. Now, to find the answer for this, it's very, very simple. You just swap these. Those are the inverse relation for this. So for this polygon, we need to find the inverse relationship and then graph both original and the inverse. Now, in the first coordinate, it was minus 8, 6. This x changes to y and y changes to x. 6 and minus 8. I hope this is clear. Over here, the y is minus 2, which becomes x in the inverse, whereas the x becomes y. Same way, you can write all these 3 points. Now, when you graph, you can see the original is given by m and p over here. M and let me change the color over here. It is m, n, and p. But the inverse varies. Inverse is different. All you need to do is plot these points. See, the m point was at minus 8 and 6. That is negative 8 and 6. But now it is positive 6 and negative 8. It's completely changed, isn't it? There's a jump from here to here. Same way over here, n and n dash jumped over here, and the p, it's changed. But what you can see is this is the inverse relationship. And if you draw a line of xy, you draw a 45-degree line, which needs to be like this somewhat. These both will be inverted from that particular point. So you can see this point is over here, this point is over here, this point is, it's all reflected along xy line. We will see that in the see about that line further in the next type of problems in the same topic. But now quickly, let's see over here. If it's 7 and 7, it doesn't matter. It's the same. See, 7 and 7 is same. Whereas these all changes. Let's see where is 7 and 7. It's over here. Even when you reflect it, it'll be the same because it's along the xy axis. Okay, the points on the x equals y line will never change. So this is very basic and very simple. All you need to do is swap x and y and then find the points and then graph them all. You will get the answers. So this was easy, but what about the next type? You need to find the inverse of a function, not a relation of a function. What do you do now? Again, we need to implement the same concept, the same idea which we just now learned, swapping x and y. But you can't just swap over here. There is few steps. The step 1 would be write the given function in terms of y. Instead of f of x, I will write it as y. So what do? Change this. Now it is y equals x plus 2. Okay, what is next? This is fine. Y equals x plus 2. What do I do next? The next thing would be over here swapping x and y. This is the concept what we have been doing over there, interchanging x and y, right? So the same thing, swap x and y, that means interchange the points. Now over here this is the same thing. Instead of y I will write x, and instead of x I will write y. So now whatever the answer I can see, can you see this? Now, this is the inverse function, but whenever we write a function, we write in terms of y. We write y equals to. So now, rearrange and solve for new y. This is the important thing in the same step. Swap and solve for new y means keep y at one side, take everything else to the other side. So y, let it be positive, take this 2 to the other side, it becomes x minus 8. And now y equals x, sorry, not x minus 8, it is x minus 2. So y equals x minus 2. Okay, now it's y equals x minus 2. So what do we do next? We need to replace y as f inverse x. That means this is the given function f of x. We just can't keep y. We have done so many steps. So whatever that function is, the inverse function. So replace this y as f inverse x equals x minus 2. And that is it. That's the inverse function. Now if you're graphing this, you can see x plus 2 is over here, x minus 2 is over here. Now what things can you understand from this? One thing is, what is the inverse of plus? Inverse of plus is minus. So x plus 2, it will become x minus 2. If it was 2x, it will be division. Multiplication becomes division. We will see all that in a while. We'll compare it. But before that, this is very important. This is the xy line. The x is equal to positive y. Now here all you need to do is plot. See, it'll be always reflected along xy line. If you graph one of the function, you can see this is the function. So now if you get this in exam, then you should just know the basics of the graph. Since x is plus 2, instead of the origin, it's plus 2 over here. And this is minus 2, so it's down. But if you know one of the graph, it's enough. This is plus 2. You need to just reflect it along the xy line. So that's it. So this is how we graph it. But now what if it's a complicated problem? Because this is a very basic problem, right? Now what if something like this? Sorry for that. The animation has gone a bit error over here. But anyway, step 1 would be right in terms of y. The same steps. It's not changing. It's the same thing. Right in terms of y equals 5x squared. Now swap x and y and solve for the new y. What you do is, over here, instead of x I put instead of y I put x, and instead of x I put y, and then solve for y. Take the 5 to the other side. Take square root. Square root on both the sides. Over here it will be square root x by 5. Now that means, remember, always when there is a square root, what does that mean? It's either plus or minus. So now y equals plus or minus square root x divided by 5. Now this is the answer, but generally your textbooks and everything will have in terms of, say, now since you have x by 5, okay, this is entire thing. Now what happens is they generally multiply this by 5 up and down. So what happens? Over here it will become 5 squared, square root 5x divided by 5 square. This cancels out, so you will have only 5x as square root, and below it will be 5, because 25 square root is 5, so this is 5 square, right? This cancels out with the square root over here. So this will be answer. Don't forget the plus or minus. Square root 5x divided by 5. Now replace the y as f inverse of x. So over here y becomes f inverse of x plus or minus root of 5 x divided by 5. How do you understand which is plus or minus? Over here, sorry, let me just, okay. Over here, this would be the answer. This is the graph. Over here, you can see it's reflected along the xy. Now, this is something which is crucial. whenever you have plus or minus, see which is the domain over here. Whenever the domain is from minus infinity to 0, this is the reflected part. Okay, from here to here, this is the reflection. So that means since it's in the negative region, this will be down. Whereas if it was from 0 to positive infinity, the domain, then this would be the positive one. How would you understand? Because if I graph, say, plus root of 5x by 5, I know the graph will go like this, upwards, right? That's the graph. Whereas if it was the same thing, if I had just minus over here instead of this plus, then it would go something like this. That's how we understand. So the domain restriction is, that's it. So that would be the answer. Now you can see over here all the answers. Okay, I had told about 2x inverse would be 2 by x. I'm sorry for that. It is 1 by 2x. Okay. Now we see 5x, inverse of 5x would be, this is multiplication, so you must divide 5, right? So x will remain, you should divide that by 5. Now 5x is 5 times x. Now you just divide this 5. Same way over here, x plus 2 becomes x minus 2. So you can find this relation, but it's a bit tricky when it's complicated. So the best way would be the steps which I just now showed you. You can just go to the previous section and see the video, just see the problem in detail is explained. Now we always will be reflected along xy line. You can see over here, the reflection is along xy line. Similarly, you can keep continuing over here. So same way, but try to use the steps and solve. You'll get this over here. Now, over here, if it was only graph, it's very, very simple. If you know one of this graph, because this is simple, it's minus 2x plus 1. That means it's going downwards and the y-intercept is 1. Then it should be just reflected along xy line. So that would be the answer. Now, similarly, please do try them by yourselves. Use the method, try them by yourself. To find this, it's better to use the steps and then solve. Similarly, over here, they're very, very straightforward. Please do solve them by yourself and then check the answers. Now, over here, the last two, I want to point out there's a mistake over here. I have done this anyways. It was just a while ago we discussed this. It is 5 root x. Okay, this x should be under root. It's square root x only. Only then it would make sense. The graph would make sense. Otherwise, it's not, because this is a square root function. That's the thing. Over here as well, just the only thing is whenever this square. Now, 1 minute, I'll just quickly go back. You can see there is no square over here, so it's fine. There won't be any, domain restrictions or anything. Only over here, because there is a square root function, square, when you do the inverse, there'll be plus or minus. So one case would be minus, that would be the domain restriction from negative infinity to 0, and the positive side would be the from 0 to infinity. So it's very simple. Just go through these, solve it by yourself, and practice. That's it for this topic. In the next video, we will move on to the next topic. The ninth topic, it's a basic one because you have options. You can easily find out which is the correct answer, but how to actually solve this. I won't go into the long method. You might have already learned that in your regular classes, but I will tell you a simple method. Split the numbers, split the variables. And over here, since it's plus or minus 3, you don't need to bother about anything. Just write plus or minus 3. Square root of 121. You need to know this. You can use your calculator, but otherwise it's 11. You need to remember. You should know this in your mind. This is, say, 15. You can use a calculator, but it's better to know the squares of 1 to 20, or at least 1 to 15. It'll be very useful. Or at least some of the important numbers. You must know from 1 to 10 by heart, because it'll be much helpful for you when you solve problems. Now here, what does the square root mean? If there is nothing, it's called square root, right? Because the number is 2. You should assume it to be 2. It's always 2 if there's nothing. So what that means is x, the power is 4, right? Whatever is over here in the radical, it is divided by. Same with y, power 16 divided by 2. That's it. That's the answer. So it'll be 11 plus or minus 11, x to the power 2, y to the power 8. That is the answer. Now I will show all the answers. You try it by yourself. Um, you better pause the video now. Try it by yourself. You may not get all correct because now I'll just show the answers. You can see some of them have magnitude, some of them do not have magnitude. Look over here, there are variables with and without magnitude symbol, and over here there's negative. What's going on? So first thing, the sign, it depends on the given question, plus or minus, or if it's minus or if it's plus, just write it as it is. Don't bother about the sign, it's very basic. Now, what happened? Why do you write this magnitude? So this is another important one. Now, whenever you divide this, whatever the exponent is there over here, the exponent is 2. You divide 16 by 2, it's 8. 36 by 2, it's 18. So it's fine. There is some power over here. That's the even power itself. It's fine. But whenever you get an odd power, or you get no power at all, like, I mean, 1 is odd, that means it's not written. You don't write y to the power 1. You just write y, isn't it? So when it is an odd or not given or any odd number, you will see this. See over here, for 1, over here it's 3, odd power, again over here 3, all the odd powers and 1. Why do we write that? Look over here, we are telling it's the solution of this, right? So can a square root over here, all are even, can a square root of even number, this one, can minus sign be there inside? No. So 49 x to the power 4, all is positive, so it'll be plus or minus. Even if it is minus, when you multiply twice, when you multiply this 2 times, you know what's going to happen? Minus 7 times minus 7 is positive 49. So that is why we write plus or minus 7, because if it's 7 times 7, it's 49. Yes, even if it's negative 7 times negative 7, it'll become positive 49. And this x to the power 4, it becomes x to the power 2. So if I take any number of x, say let me take minus 2, it'll become whole square. That's a positive number. So this is the correct solution. But now when it's single numbered, say over here, because you're dividing by 8, x squared, y, 8 by 8 divided by 8 will be 1. Now you can't have a negative number for y. Even if it's minus 3, you should make sure you have a magnitude sign, because the answer must be 3. Because if you put it back over here, remember the solution, the inside value must be positive, right? Inside is square root or even radical. So that is why only when you have odd numbers, this is there. How to remember if you're not understanding all the concept? It's fine. All you need to remember is whenever there is a odd reduction, over here it's odd number, there's odd numbers. So over here also 3 is an odd number, 3 is an odd number. You need to make sure to use the radical, the magnitude symbol, because the whole answer over here doesn't matter positive or negative. You must take only the positive answer, whereas the numbers and all just can be written out. And what about this one? See, this is a cube root, right? When it's cube root, it doesn't matter at all, because if it's minus also or positive also, it doesn't matter. You will get the correct answer. I'll just quickly show you one thing over here. So this one over here, 121, it's 11. Negative 121 is an error, right? But let me take cube root now. Okay, this is the cube root. I'll just put 3. 121 is over here, it's not 11, sorry, 4.8. Let me take another one, 64. I know the 64 is 4 to the power 64 is 4, but let me take minus over here. You're going to get minus 4, because this doesn't matter over here. You can even have negative numbers only when it's even number, say 6. This is error. Why? Because you can't have negative numbers, it must be only positive numbers. So this is the thing behind it. I hope it's clear now. Whenever you have odd numbers, remember you must have the magnitude sign when you solve it and get odd powers. See over here, d to the power 1 is odd, that's why. So one more thing, look into the other options, solve them, and then you can easily relate it to the question, and you can definitely choose the correct question. So look into the other options, and then you can deduce the correct answer as well. Now we are in the last topic of the part 1 in your end of term 3 exam syllabus, exam coverage, sorry. Now here they have asked you to simplify expressions of exponential or radical form. We had simplified expressions on radicals or radical exponents just a while ago in the topic number 9. If you have not watched it, please go back, watch the topic 9 and then come over here. So what did we learn over there? If I had, say, a like this, 8, radical, it's square root 8. We just write 8, the power over here is 1, and whatever is over here is divided by 2. Now it's other way around. How do we write it? What is the power? 8. Okay. Then put the square root symbol. This, or if it's nothing written, it's 2 itself. So this is the answer, right? Same way, write this 8. Use the radical symbol. It's 5. That's it. That's the answer. It's very, very simple. Now, what about 4 to 7? 4 to the power 2 by 7. Whatever is up, it's to the 4. It's power raised to the power 2. And whatever is down, write it outside the radical symbol. So simple. Okay, now over here, this 4 square, radical by 7, that's the answer. But 4 square is equal to what? 16. This is 16, so this is the answer. So whenever you solve, if it is not there in your answers, don't panic, don't worry. Just make sure you simplify it further, or just rearrange terms, and then you can get the correct answer. Here, the same thing, x to the power 3, and there is 3 by 2 again. So this is equal to, multiply this, whenever power to power, this power, x cube is raised to the power 3 by 2, you multiply these both, it's going to be 9 by 2, isn't it? It's going to be 9 by 2. So x to the power 9, I'm sorry, and take the square root. You don't need to write this 2, it's understood. If it's nothing, that means it's 2x to the power 9. Same way, please do try the others. Over here, there's nothing, so it's half. And over here, you can simplify. You need to simplify for all. Phi, 1 by 3. X to the power 1 by 3. Y, 2 by 3. Same way over here, you can solve this. Now, one quick thing. If at all you just forget somehow and it's just numbers, then you can use your calculator. Say, for example, sorry. Now, over here, I have, say, root 17. The thing is, you're not going to get the correct, okay, root 17. You're not going to get an exponent form. Now, this is not a better example. I'll take this, the first one. It is 8 to the power 1 divided by 5. You can use the fraction symbol, 1 by 5. You're not going to get cube root, a radical of 5, radical 5, 8. No, it's not going to happen like that. What's going to happen is you're going to get fractions. Sorry, decimals, 1.515716, and goes on, right? What do? What you must do basically is you need to see all the 4 options and simplify. So now over here, this one, when I simplify, shift and this, and now power 5 and 8 over here, I'm gonna get the same answer. So you can do this and check with all the options. It's a long method, but this is such a simple problem. You don't need to do it. It's fine, So now the distance, okay, there are 2 real world problems. The distance in millions of miles of a planet is from the sun in terms of t, the number of Earth days. Sorry, let me read it again. It's about orbiting. I don't know what happened. Maybe I'm just tired. The distance in millions of miles a planet is from the sun in terms of t. The number of Earth days it takes for the planet to orbit the sun can be modeled by this expression. Write the expression in exponential form. All you need to do is simplify this to exponential form. Nothing else. It's just that they're telling that this is the equation given over here. All you need to do is in exponential form. 6, 1 by third, t, 2 by thirds. Same thing over here, you can simplify it. 1 minus, the only difference over here is they have told you what is the value of P. The P original price in dollars is given as 52425. Okay, so all you need to do is instead of P, you need to type 52425. You need to write, sorry, not type. And then what is N? N is 8. They have also mentioned N over here as 1 by n, that is 8. So you need to write in radical form. So this, whatever is inside it, remains 4 to 5. This just remains, and what remains, or what's the radical? It's 8. 1 minus. So that's the answer. It's just rearranging. It's very, very basic. Please do it by yourself and then check the answers. Over here, there are a few more problems. They are again same. Now, these have to be simplified. It's basically cube root of 27, that's 3, or you can just use the calculator. You can just save time. Say, for example, 16 to the power negative fraction the power 5 by 4. What's the answer? It is 1 by 32. You will get the answer exactly in the calculator, so don't waste time for this. If this problem comes, you can just solve it in calculator. So try all and just check it with the answers. It should be correct.